right, so I'm going to go through and I'm going to provide you with 2 more examples of how to draw Lewis dot diagrams or Lewis dot structures. So the first step that I always take is I count my number of valence electrons. So carbon is in the group that has 4 valence electrons. Hydrogen has 1 valence electron, but there are 3 of them. And then bromine has 7 valence electrons. So if I add this all up, I end up with 14 valence electrons. My next step is to share the electrons. So carbon is going to be my central atom because it's first, and I've got 1 of them. Then I've got bromine and 3 hydrogens. Okay? And what I'm going to do in this step is I'm simply going to share electrons by using a covalent bond for each of them. Okay? And then my next step after I share electrons, I'm going to give lone electrons to my outermost atoms and then to my central atom so that they can fulfill the octet rule. Specifically, the octet rule tells us that atoms are most stable when they have 8 valence electrons. And the only exception to that is hydrogen, which is most stable when it has 2 valence electrons. So let's look at bromine first. I'm going to do my outermost atoms first. Bromine right now only has 2 valence electrons from this covalent bond. So I need to add 6 more. And so I'm going to add 2 more up top. This line represents 2 electrons, 2 here and 2 here. So that's a total of 8, 2, 4, 6, 8. Notice I put the lone pairs of electrons where I did versus putting one right here because that would interfere with the covalent bonds that I drew right there. Okay, so that's bromine. Bromine is content. Hydrogen, I need to make sure hydrogen is content now. Keep in mind, hydrogen only wants 2 valence electrons, so it's got 2 by having this covalent bond. And this hydrogen is content, and this one is content as well. And finally, if I check for carbon, notice it has 4 covalent bonds, which would equal 8 valence electrons, so it has a complete octet as well. Now, we're going to use our Vesper model in order to see what this Lewis dot structure will actually look like so I can draw it properly. Remember, what the Vesper model tells us, molecules take whatever shape helps to minimize electron repulsions. Okay, so let's actually look at how that plays out by looking at the simulation on this website. All right, so for CH3Br, I've got 4 total atoms attached. So imagine this atom right here is going to be my bromine. Okay, this is what the structure looks like. Okay, so the way that I like to draw it, I like to have 1 atom going up and then 3 going downwards. If you can show this 3D shape, awesome, but I like 1 up and then 3 down. All right, so based on what you just saw, you're going to have carbon as a central atom. You're going to have, it doesn't matter what atom's on top. It can be hydrogen, that's fine. I'm going to put bromine on top. And then you're going to have, it showed 3 atoms like this, kind of one coming out of the page. Now, I can't draw in 3D, so I don't expect you to be able to. But this is what the Lewis structure for CH3Br looks like. The last step is that I need to check to make sure I'm using the correct number of valence electrons. So looking at bromine, I've got 2, 4, 6 that I'm using, 8, 10, 12, 14. I am using the correct number of valence electrons, so my structure is correct. All right, let's look at one more example, OF2. So again, first count valence electrons. Oxygen has 6 valence electrons. Fluorine has 7, but I have 2 fluorines. So this is going to give me a total of 20 valence electrons. My next step is to share. So I'm going to have oxygen as my central atom. I'm going to have a fluorine here and a fluorine here. I'm going to share electrons using a covalent bond. Then my next step is to add lone pairs of electrons. Remember, fluorine wants 8 valence electrons. Right now it only has 2, so I'm going to add 4, 6, 8. Fluorine here has 2, 4, 6, 8 now. And oxygen has 2, 4, so I'm going to have to add 2 lone pairs, 6, 8 valence electrons. Okay, let's look quickly at what this would look like by using the Vesper model. Okay. So for OF2, I've got 2 fluorines off of my oxygen, and then I've got 2 lone pairs of electrons on the oxygen. So notice this shape is going to be bent. So this is how I like to draw it, okay, with 2 pairs of electrons on top, and then my fluorines going downwards. If instead you want to flip it, right, have the oxygen on bottom, you totally can do it. You can have your fluorines on top and your oxygen on bottom, okay, and I'll show you how to draw both of those in just 1 second. But this is your shape. Play around with it, but it's the bent shape. All right, so what you just saw is the following. You saw that you would have oxygen as your central atom, your fluorines are going to look like this, okay? You still need to have the lone pairs of electrons here, and they're pushed downwards versus being linear because you've got the lone pairs of electrons on top. If you notice with manipulation, you also could have drawn it, if you just flip the molecule, you can draw it like that. That's totally fine. Okay, so you can draw it however you want. It just needs to be clear that there's this bent structure to it. So remember, the last step that I need to do is I need to check to make sure I'm using the correct number of valence electrons. So I want to be using only 20 valence electrons. Oxygen has 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm using 20 valence electrons, so I'm good to go.